Hello guys, this is Temudan. In this workshop, I am going to give a basic overview of the electronic components that we are using in the Model Rocket project. Before starting, I just want to say a basic thing that in every project you might see there are a number of divisions are working. For example, in our Model Rocket project, there are different teams are working. For example, mechanical team, electronics team, and propulsion team. I will say you have to complete this project by considering the mechanical team and propulsion team. Is it possible? No, it is not possible because the control system which is required for controlling the propulsion and mechanical system is designed by the electronics components. So electronic components plays an important role in every project. So we cannot complete this project successfully by neglecting the electronic parts. Now, what you will learn in this workshop? In this workshop, you will learn the basics of Arduino. That is, what is an Arduino, how it works, and its uses. You will also see some interesting projects using Arduino. And then you will see the basic sensors that we are using on the Model Rocket project and their uses. How can we are implementing the sensors in our system? Come to the first topic. That is Arduino. What is it? How is it useful? And how to use and simulate it? Arduino is basically a microcontroller board. You might have heard about the term microcontroller. Microcontroller is nothing but integrated circuit which contains processing units, memory units, and some input output ports. It mainly does a specific work when we insert some specific code into it. For example, you want to do a project in which you have to blink the LED. Then how it can be possible by using a microcontroller board? You have to just put the corresponding code into it and then run it. You will be able to see the blinking of the LED. I will just show it later by some simulation. You can see this is the microcontroller. Aside microcontroller, there are a number of components like this is a power jack to supply power. This is a voltage regulator. This is the USB port to insert the codes, and this is the reset button. These are the analog pins. These are the digital pins, and these are the 5 volt and 5 volt and 3 volt, 3.3 volt pins. This is the ground pin. The interesting fact is that Arduino is an open source platform. It is easily available in the market. You can buy it from the market and use for different projects, whatever you want. As a beginner, Arduino is more convenient and interesting for you to start in project. You can see this is a bare board. We have just connected the LED through a resistor to the battery and started the simulation. When we started the simulation, the LED shows a normal glow. Then this is an interesting project using the Arduino. We have just written the codes and started the simulation. You can see the LEDs are blinking one by one. This is very interesting. These are the very easy projects to do. Even if you do not have any real components, then you can also do this using online simulations. During the current lockdown situation, we are not able to show you practically this projects. But we can use some online simulation softwares like Tinkercad to do this interesting project virtually. Tinkercad is one of the best online simulation software For beginners to start, let us see how can we use Tinkercad to perform different experiments with Arduino.
So here we are. Welcome to the tutorial, guys. Today we are going to see how can we simulate Arduino in Tinkercad. So just search Tinkercad in Google and click on the first link, that is tinkercad.com. So while it is loading, yeah, it is here. So you have to make an account. I have already signed in with my account. You have to make an account. It is free, of course. When will you finish making an account, you will get this dashboard. For simulating in an Arduino, select circuits, then create new circuit. This will load a new circuit. Okay, so here you can change your name, Arduino simulation. So you must be wondering what an Arduino is. So basically an Arduino is a microcontroller. You can say it is a brain. You can actually sorry yeah, you can actually control many things from an Arduino. For example, from your laptop you cannot control an LED, you cannot control a motor, but from an Arduino you can. uh, Basically this chip here you see, this chip is 80 mega 328p. This is the main brain, and rest of this is are the power circuitry and the pin headers. These are called pin headers. This is given so that you can easily work with an Arduino. When you have an if you have an Arduino on hand, you can easily see that. So yeah, so today I will show you how to make a circuit that will just make an LED glow, I suppose. I mean blink, yes. So let's get an LED. Let's search for an LED code. Here, let's search for an LED. Here you get an LED. And because LEDs are current sensitive, so you have to have a resistor, else it will draw a huge amount of current, destroying the Arduino and the LED board. So you see that one is anode and other is cathode. You must have learned previously also that what are anode and cathode. Basically this is the positive terminal and this is the negative terminal. You have to have an resistor here. You can have it either way, it does not matter, as you must know because we all have passed JE, I suppose. So here you can just click on any of the terminal, that is here the written is just terminal 1. You can connect it to a pin. Basically these all are called pins of Arduino. So 13, 12, 11, 10, 9, 8, these are all digital pins, and A0, A1, A2, these are all analog pins. You can generate only digital voltages, that is 0 and 5 volt in case of an Arduino, and you can generate analog voltages here, that is anything between 0 and 5 volt. You can actually generate anything between 0 and 5 volt from these digital pin also, but it is an advanced concept and I will not dwell in that here. So yeah, so you connect this terminal to, let's say, pin 3. You can connect it anywhere from pin 13 to pin 2. So and connect this to ground. Here we go, we have connected it to ground. Okay, tidy it up a little bit. Yeah, so yes, so let's color this black for now and let's color this red. Okay, so one of the great things about this simulator is that you can easily code it without knowing the actual text code. But I believe that that it is good that you learn the text code also. This is the text code, as you see. let's just go back to block. So you see that I have connected it to pin 3. So let me just set pin 3 to high. That is high means 5 volts. Okay, I can uh, I can delete this part. Then I will wait for 1 second, and then again I will set pin 3 to low. Then again wait for 1 second and then repeat this whole sequence. So this is easily generated block code. Now let us see the text code also. So you will find this tough, I think, in for beginning, but it is fine. As you will experiment with it, you will get a hang of it. So this is a function called digital write. Basically, digital write means you write something to the pin. That is, either you write a high or you write a low. High means you toggle the pin on and it is 5 volt, and for low, that is ground. Delay gives a delay of 1 second. That is, if you toggle this high, then delay of 1 second will pause the code, and the pin 3 will remain high, and the delay of here 1 second again will pause the code, and the pin will remain low for 1 second. You have to set pin mode for 3 as an output, because it can also be used as an input to read in the data. You can experiment with that also in future. So let me just start the simulation now. So you see the simulation, you see the LED glowing and blinking. See that blinks 1 second, stops, and again blinks. So this is only just a basic example. You can make many exciting things from it. Let me show you. Let us close this code. There are many components present here. You can experiment with them. There are vibration motors, hobby gear motors, RGB LEDs, and photoresistor. You must not know what are a photoresistor, but if you make a Google search quickly, you will find that. So this was it, guys. I take a leave now. Thank you.
Now come to the second topic, that is sensors. The first sensor is MPU6050. The MPU6050 is a micro electromechanical system. It consists of 3-axis accelerometer and 3-axis gyroscope. It helps us to measure velocity, orientation, acceleration, displacement, and other motion-like features. When we launch our rocket, we must have to know the velocity, orientation, and acceleration of the rocket at every altitude. So, in this case, MP6050 plays an important role. It has also an onboard digital motion processor, which is capable of processing complex 9-axis algorithms. All of you can see this is the digital motion processor. Now come to the next sensor, and that is BMP280. The BMP280 is an absolute barometric pressure sensor, especially designed for mobile applications. The BMP280 sensor is a low cost pressure and temperature sensor with good accuracy. As all of you know, the pressure changes with change in altitude. So this sensor can also be used as an altimeter with an accuracy of plus minus 1 meter. It can measure the pressure from 300 hectopascal to 1100 hectopascals. It has also very small dimension and consume very small power. It is very convenient to implement in battery powered devices like GPS, watches, mobile phone, etc. Come to the last sensor, that is HMC 500 3L, which is a 3-axis digital compass. The main purpose of this sensor is to measure the strength and the direction of magnetic field at any point in space. Guys, you can see this is the HMC 533 sensor, and these are the filter capacitors used for the filtering purpose. Now, how can we establish a communication between the microcontroller and the sensor? We generally use two types of communication protocol. First one is I2C communication protocol, which stands for inter-integrated circuit protocol, and the second one is SP communication protocol, which stands for serial peripheral interface. In HMC 533, we can use I2C communication protocol, but in BMP 280, we can use either I2C communication protocol or we can use SPI communication protocol. In MPU 6050, we can use only I2C communication protocol. Guys, this was a basic overview of the sensors that we are using. And I hope you will be able to understand. Thank you.